Hi, welcome to my YouTube channel. I am Nathaniel King and your host for this session. I have over 25 years of experience in working with computer software and over 7 years of experience working with cloud and AI. In this session, we will explore Azure integration core principles. Now, we must why must we know the integration process software engineering perspective? So we will, when we talk about Azure integration, it's not just about connecting applications. It's software engineering at system level. Here, why understanding the integration process is essential from a software engineering perspective. So there are a couple of points we need to think about. So integration is a system of systems. So what I'm saying is every system you talk about, let's say, for example, Salesforce, Workday, Dynamics, Maximo, ServiceNow, take anyone. So all of these systems are, they have, all of them has its own mini ecosystem. So integration is how they collaborate, they talk to each other. If you don't understand the full process, you can't manage data contracts, sequencing, or dependencies between them. I mean, it's a trouble. So, second point we can talk about is architecture depends on process awareness. So, just like a software design, where we separate concerns into layers, like for example, UI, business logic, and data, integration also has layers: ingress, transformation, routing, and egress. Knowing the process ensures you design loosely coupled and maintainable workflows instead of tangled ones. So the next point is reliability and security aren't afterthought. I have seen many times in my career that teams think about reliability, security, resilience after, or not one more thing, also thinking about governance. So I have seen those things. People tend to think, okay, it's not very important. We will take care of those things later. However, I found something different. If you leave those things for later, it never happens until unless management shouts at you and system goes down and something else happens. Until unless those things never happen. I mean, in real life, people do not tend to go back to the same system once they're finished. So it's kind of persists for a very long time. Now, in software engineering, we build for fault tolerance. In integration, that translates to retries, dead letter queues, circuit breakers, and secure endpoints. Without process visibility, failure cascade across systems. And I have seen this thing happen many times. The next one is it prevents spaghetti integration. We just spoke about, when we have multiple systems, they're going to talk to each other. So when they talk to each other, sometimes what happens is when we are in a hurry, we try to connect, as simplistic way we can, and we try to, just do translation as it is. I mean, middle layer or the integration layer understand completely everything about how to translate these things and how to system A to system B and system X to system Y. It is responsible to translate all those things. So when you skip design steps, every system ends up calling every other system directly. And I have seen this thing. That's like writing one giant function with no structure. Understanding the process helps you implement clean architecture principles, modular flows, reusable connectors, and canonical models. So we'll talk about canonical model later on, or might be a separate video, why we need them. It supports DevOps and continuous delivery. Knowing how data moves through the pipeline lets you design CI/CD for logic apps, functions, and APIs with proper test cases and rollback strategies. So if you have continuous delivery in place, you have much more, from governance point of view, it's much more easy to manage systems, deliver them, and with less errors and challenges. So integration testing becomes predictable and instead of trial and error. The next point is it creates foundation for scaling and automation. So when we have DevOps, we have it's easy uh, to basically migrate applications from one environment to another environment and with less problem. So when you understand the integration process, you can automate deployment using various tools like Bicep or Terraform, monitor flows in application insights, and scale individual component without affecting the whole system. So there are a couple of points I just gone through. Let's move on to actual flow, how it looks like. So now in the diagram you see this is my perception of integration, and it can change from your point of view might be different, but what I understood in the last couple of years of experience in integration, that these are the prime or basic steps we need to take care in any integration implementation. The first point is step zero, define the quality standards for design, coding, and documentation. So we have to make sure that before we actually jump into understanding systems and documenting it, cataloging it, or writing requirements or anything we decide to do in integration or any other system, we must have defined quality standards. So that's a step zero. Now, step one is identify the stakeholder uh, and understand the business problem, process, and data flow. I'll just go through these one by one. Let's just quickly run through, and then we talk about a little bit more on these things. Step two is identify the system involvement and document them. The third is choose the right integration strategies and patterns. Step four is design and document the integration and review. Step 5 is build the integration components. Step 6, test and validate end to end. Step 7, deploy and monitor. Step 8, maintain, improve, and scale. Step 9, continuous improvement and knowledge sharing. So let's go through them one by one. So step 0 is define the quality standards uh, for design, coding, and documentation. Before any integration project starts, there's a one step we often skip, and it's the most important one. We call it step zero, define the quality standards. This step ensures every design, every line of code, every document meets a consistent benchmark. No matter who builds it or where it is displayed, let's start with this step first. So, and it starts with the first thing is design from design point of view. So design, every integration solution should follow the Azure well-architected framework principles: reliability, performance, security, cost efficiency, and operational excellence. So it's a Microsoft Microsoft established standards. So we must follow in our design. So we don't design in isolation. We use approved tools and templates, consistent naming standards, maintain architecture diagrams that tell the whole story from API management at the front to the logic apps, service bus, functions, and data services at the back. Design reviews are mandatory. They are not just about catching mistakes, they are about sharing insights and maintaining architectural discipline. That's where the Design Authority Board adds a real value, right? So the next is coding and development. So in the same step, so developers follow a common coding and branching guide. Whether you are working in logic apps, functions, or bicep, the principles stays the same: readable, reusable, observable, and secure. Every repository follow a Git flow or a trunk-based strategy. Pipeline are automated through Azure DevOps, and we measure code quality with Sonar Cube. Now, testing and deployment aren't afterthought. We need to think ahead. They are built into pipeline. Each PR triggers automated tests. So quality gates are enforced early, not in production. So it need to be done. It's called moving for left. Moving left means doing testing as much as possible in the development and testing before go anywhere. So the next one is um, documentation. So we tend to ignore these things sometimes, documentation and governance. So every solution must have a traceable artifacts, design documents, interface specs, deployment guide, and run book. uh, they all have some traceability. Vendors must follow the same templates. So sometimes what happens is I've seen there are multiple vendors. They offer their own design templates, and sometimes we tend to say, okay, yeah, let's use that template. No, we need to have, as an organization, we need to have a standard, and that standard will be must be followed by any vendor joins us and deliver any product to us. They have to follow that standard. They can't just do their own stuff. All documents are version controlled and reviewed during the release process. The results of all those this thing are predictable, repeatable, scalable integration practice. So what we are saying here is we need to have clear cut quality standards. So if you do not have any standards, nobody will adhere to it. They will just do whatever they want to do. And one that